As we saw in the last video, the coordinates of any point on the unit circle are defined to be cos theta sine theta, where theta is measured anti-clockwise from the positive x-axis. So, for a point in this quadrant, we are dealing with a reflex angle. That is an angle between 180 degrees and 270 degrees. Let's take an example. Suppose theta is 210 degrees. Then the coordinates of this point are cos 210 degrees, comma sine 210 degrees. We can see that the coordinates of a point in the third quadrant are both negative. So the cos of a reflex angle, well, an angle in this quadrant, is negative, and the sine of it is also negative. So we have them here as well. And of course we can move this point around. We just still deal with angles in the third quadrant. We can see that both the cos and the sine are negative because the coordinates are negative. The cos and the sine are just the coordinates of this point. However, we see that the tan is positive because remember, the tan of theta is just sine theta divided by cos theta. Minus 0.5 divided by minus 0.866 is plus 0.5774. When theta is 180 degrees, we see that the coordinates of this point are minus 1, 0. So the cos of 180 degrees is minus 1. The sine of 180 degrees is 0. The tan of 180 degrees is 0 divided by minus 1, which is 0. At the other extreme, if theta is 270 degrees, then the coordinates of this point are 0, minus 1. That means that the cos of 270 is 0, and the sine of 270 is minus 1. Now the tan of 270 is sine over cos, so we're dividing minus 1 by 0. We have division by 0, so that means it's usually undefined. Actually, the tan is approaching negative infinity as theta approaches 270 degrees. Notice here that since both the sine and cos functions are negative for angles in this quadrant, the tan function, which is got by dividing sine by cos, is going to be positive. So for angles in the third quadrant, only the tan function is positive. Actually, when we get to theta equals 270 degrees, the tan function jumps to minus infinity. So this is not true, of course, here, but since this value is undefined, we just ignore what happens at 270 degrees. So we call this quadrant the T quadrant to indicate that only the tan function is positive, except at 270 degrees where it's not even defined. So the T means only the tan function is positive. That means the other two functions, sine and cos, are negative. Similarly, to go back here, S means that in this quadrant, only the sine function is positive. The other two functions are negative. And over here, all functions are positive, all three of them. Now let's see how we can relate the sine, cos and tan of an angle in this quadrant to the sine, cos and tan of an angle in the first quadrant up here. To do that, we reflect this point through the origin. So we get the image of this point under central symmetry in the origin, and we'll get a point up here on the circle. So notice the coordinates of this point. The only difference between the coordinates of this point and this point is the signs. We just change the signs when we map a point through the origin. In this example, theta is 240 degrees. When we map the point through the origin, we can also think of mapping this angle through the origin. This angle here is 240 minus 180. We get 60 degrees. So we can relate an angle of 240 degrees to an angle of 60 degrees. We know that the coordinates of this point are given by the cos and sine of this green angle here, which I'm calling A. So cos of 60 is 0.5, sine of 60 is 0.866. So we can relate the cos, sine and tan of 240 degrees to the cos, sine and tan of 60 degrees. Cos of 240 degrees is minus 0.5. That must equal minus cos of 60 degrees. That's minus 0.5. The sine of 240 degrees is minus 0.866. Well, that's just minus sine of 60 degrees, or minus 0.866. The tan of 240 degrees we have here is 1.7321. That's just the same as the tan of 60 degrees. The tan of 60 degrees is just the sine of 60 divided by the cos of 60. It would just be plus 0.866 divided by plus 0.51, which will give us plus 1.7321. In general, we have these relations. So the example we just saw, theta is 240 degrees. So we take 240 degrees, subtract 180 degrees to get 60 degrees. So cos of 240 equals minus cos 60 degrees. And similarly for sine and tan, we take 180 degrees from the angle. For the tan function, we don't change the sign because the tan is positive in this quadrant.